number 3. But on graph number 3, here's what I want to point out. From A to B, for f of x, this is y equals f of x here, we got this. Then on the graph on the right on number 3, from A to B, what, and that's g. Call that g of x. What I would point out here is this. Different shapes, right? However, as far as the first derivative goes, both of those, and I did a little too much there. What does the first derivative tell you about that? Increasing. First derivative is increasing. First derivative is positive, so it's increasing. What about this one? What does the first derivative tell you about that one? Increasing. Okay. The derivatives are still positive, aren't they? Positives. First derivative doesn't explain anything about the difference between these two graphs. The first derivative tells you this is increasing, but doesn't tell you that the graphs are different. Turns out, this is what's known, the difference between these is the concavity. These graphs have different concavity. They're both increasing, but they have different, what's called concavity. This one's concave up. This one's concave down. And it turns out that concavity has more to do with the second derivative. But we'll get to that in just a second. But this is what basically a concave up. And matter of fact, concavity, concave up, even continues on around, even if it goes up. That's concave up, like a bowl shape. Whereas concave down is more turned over like that. It's kind of a happy face, smile, frown face. Okay. That's concave up, and that's concave down. It's basically, your shape is turned down, this one's turned up. That's the idea. And notice that as far as increasing, there's an increasing part and a decreasing part here, isn't there? This is decreasing, that's increasing, but this is concave up. This is increasing, this is decreasing, but it's concave down. So it's different than the increasing and decreasing. It has really nothing much to do with that. All right, so that brings us to number 4, just kind of identifying some concave intervals of concavity here. So graph number 4 on the handout. Try to sketch it here. Yeah. Okay, let me tell you one other thing before I do that. Back to number 3, just a second. This can help you too. Think about it too. I said the first derivative has nothing to do with concavity, but there is something that can help you out. Do you notice here the lines of tangent where they are? They're below. On concave up, the lines of tangents are below on concave up. However, the lines of tangent on concave down, the lines of tangent are above. Okay? So that can help you too when you're just going off of a graph here, identifying concave up or down. Lines of tangent below for concave up, and so you have to go up for the line down. Okay. All right. So anyway, so number 4, let's identify the intervals of concavity. So concave up, concave down. CU, CD. Concave up, concave down. Well, like I said, it's a little tricky. What do you see here? Well, that one's obviously bowed down. So that's concave down, bowed downward. So I can see concave down there, and again, the tangent lines are above concave down. But at some point, you see, these are down, but then it's going to turn around. Some point in here, now let me see, the peak there's at 2. Bottom here is at 4, 6, 8. Okay. But does it break up at those peaks and valleys? Not necessarily. Sometimes it will, but not necessarily. Does the concavity change at 2? No, it's still concave down, isn't it? This is still down. Then at some point here, it changes to concave up, doesn't it? But it's not at 4 and it's not at 2. It's somewhere in between, and I'm going to say, how about we go with 3? That's where it changes. 3 is where it changes concavity, because it's not at 3 and not at 2 and 4, because it doesn't change concavities at those. So it's somewhere between 2 and 4 it changes. You with me? Because this is concave down. This. Okay. What about, is there anything change-wise there? From this 3 to this 6, x is 6. Any change in concavity? What? I said it's concave up here, but is it concave up all the way to there? I think so, isn't it? I don't think there's any change in concavity to 6. Well, of course, we got a point there, and that's derivative does not exist, so that's obviously something changed. But what about after 6? What are you seeing there? Concave up, concave down? Still concave up, isn't it? It's still bowed upwards. It's not bowed down, it's bowed up. You with me? Tangent lines, look at those two. Tangent lines are below, that's concave up. However, somewhere in here it changes, doesn't it? And I don't think it's at 8, because at 8 and a little bit after, before 8, it's concave down, because the tangent lines are up here. So I'm going to say along about 7. Yeah, maybe not even 7. Looks like here's 7 right here, and then it kind of has a little fluctuation there. It looks like it changes about 7.5 to me, doesn't it to you? 7.5. So at 7.5, it changes to concave down. So it's a little different, I know. You're used to looking at peaks and valleys, but concavity can have something change at a peak, but not at a regular one, at a smooth one, because it doesn't change concavity at a peak like that. So anyway, it's a little different. So concave down, so I would say that's negative infinity to 3. It's one part of concave down. Concave up from 3. Now, here's a good point. I do need to break it up at 6, because guess what? Like I said, the second derivative is going to tell you a lot about the concavity. I know the first derivative doesn't exist here. Why? There's a point. And so if the first derivative doesn't exist, does the second derivative exist? No, it'd be hard to do a second derivative if your first derivative does not exist. So, yeah, you kind of need to break it. Even though we don't change the concavity, there is a break, because it's not concave up or it's not concave down at that point. And then concave down from 7.5 to infinity. So anyway, okay? Is this okay? One other thing to tell you about, and that is inflection points. And an inflection point is a point on the graph, an x comma y, where the graph changes concavity. Either goes from concave up to concave down, or concave down to concave up, vice versa. Okay. Do I have any inflection points on this graph, which I forgot to call h of x, but it is h of x? Does h have any inflection points? I do believe it does. Because at 3, we estimated, we're changing from concave down on this side to concave up on this side. So yes, there's an inflection point at 3. And again, it's a point of inflection, so let's just call it 3. And since I don't have values, h of 3 would be my x comma y. You with me there? Because since I don't have the y value, I could estimate it if I chose to, but let's just call it h of 3. So 3h of 3 is an inflection point. Any others? Is the one at 6 or 4? No. We still have concave up on either side of 6, even though 6 is kind of a break, but it's not an inflection point. But I do have another one at 7.5, don't I?